So hello guys, welcome to my class. So today we are going to discuss a very interesting chapter which is sound, right? So before coming to this chapter, we'll first understand what is sound, right? So definitely guys, you are very much aware of this term sound, right? Every day you are engaged with this term sound, right? In the form of traffic signals, or in the form of traffic sounds, or in the form of like your mother and father shouting on you for doing wrong word, right? So in different ways, your neighbors, right? And different birds, different musical instruments, right? So you all are very much aware with this term sound, right? But what exactly it is, right? So this is the main concept to understand, right? So exactly if we want to like define this term sound, so we can say that sound is basically a form of energy, right? That create a sensation of hearing to our ears. This is one definition. Second definition may be sound is a form of energy that travels in the form of wave, right? So I will be writing the both the definition, but we should understand only one definition, that we should know that sound is a form of energy that travels in the form of wave. Understood? This is a very generic definition and very simple definition, right? So as you can see that in this particular definition, you will see two terms. One is energy and the second one is wave, right? So as you can see that there's a very simple and generic definition, that is sound is a form of energy that travels in the form of wave, right? So in this particular definition, you can see that there are two terms. One is energy and the second one is wave. Okay. So first, you guys are very much aware with this term energy, because you all have studied in what energy power chapter, right? And what is energy, different forms of energy you have understood, right? Kinetic energy, potential energy, right? So such form of energy you have already gone through it. But I think you are little unaware of this term wave, right? I'm damn sure that you would be really unaware of this term wave. Okay, so whenever I am taking this name like word wave, so what is coming in your mind? So definitely something like the water waves or the waves which have formed the strings, right? But what exactly it, right? So we'll first try to investigate that what is wave. Okay, so let me make you all understand what is wave, right? So I'm just focusing over this term wave, right? So first we can write here wave, right? So what is wave, guys? Let me make you all understand what is wave. So wave is basically any kind of disturbance happening in medium. Okay, so we can write it down here. Very simple definition. Key, what is that wave? Any kind of disturbance. Any kind of disturbance. Okay, any kind of disturbance happening or occurring in the medium. Okay, किसी भी टाइप का डिस्टर्बेंस होना मीडियम में, वही आपका वेव कहलाता है. ठीक है. Now the most important part is that what is the definition, is what is the disturbance, how many types of disturbance are there, that is to understand, right? कि जो disturbance हो रहा है उसका pattern कैसा है, right? That is very important to understand. And we know about the medium, right? We have different medium like solid, right? Liquid, gas, plasma, and both sides and condensed. There are different types of medium that we know, like states of matter, right? We have gone through that. But basically the medium that we are talking here is solid, liquid and gas. So how sound propagates, how sound travels in these three mediums, what is the pattern of movement, what is the pattern of travel, right? So we'll see very carefully, right? So first is that when we talk about this term wave, so any kind of disturbance that happens in the medium, very simple, right? So this is the simple definition of wave. Now we'll understand that how many types of waves are there, because now we have understood the concept of wave. Now we'll see that how many types of simple waves are there, right? So when I define waves, so waves are basically, okay, so when I see waves are basically categorized into two ways. Okay, one is mechanical wave. Okay, this is the mechanical wave, and the second one is non-mechanical wave. Okay, one is mechanical wave and the second one is the non-mechanical wave, right? So first I will go with this mechanical wave. So with the name only you can say that mechanical. It means that such wave requires the material medium for its propagation, right? When I define this term mechanical waves, so we can say that any kind of waves that need some material for its propagation, right? So we can simply define that the waves which requires any kind of material, okay, any kind of material medium, understood? Any kind of material medium for the propagation, understood? Propagation, okay, means any kind of we can say that any kind of material, right? Any kind of medium, material medium, understood? This is very important. Any kind of material medium that requires for its propagation, right? What would be the example? So there are various examples of the mechanical wave. So we can say that example would be very simple. We can write it down. Example, like we have sound wave. Sound wave requires actually material for its propagation, and that material medium may be solid, liquid, gas, right? Second, maybe like waves on string, understood? किसी एक string पे जो wave बनता है ना, that is also example of material wave, right? Mechanical wave, because that is requiring some material medium. And the third one will be I think very simple, that is the ripples. Water ripples, okay, water ripples, right? So these are basically some of the example of mechanical waves. It means that such waves require really some material medium for its propagation. Now I am coming to the next, that is non-mechanical wave. So what would be the non-mechanical wave, right? Very simple. So we can simply define non-mechanical waves just opposite of mechanical wave. It would be very simple, that you can say that the waves, you can say waves which didn't required, understood? We didn't require any material medium for its propagation. The material that waves which didn't require any kind of material medium for its propagation, means the waves that didn't require any material medium. So what would be the example? The best example is vacuum, right? It means that the example, when I talk the example, the example is very simple, that is all kinds of radiation, all radiations, okay. And second one will be very simple, electromagnetic wave. Electromagnetic waves, or we can say light, because light is also form of electromagnetic wave, right? So these all are the example of very simple non-mechanical waves. It means that it doesn't require any kind of material medium. So what would be that material medium? That material medium will be very simple, the vacuum, right? So we can write one more point, that it can travel in vacuum, okay. So it can travel in vacuum. So these are basically two types of wave that we have gone through it, right? Now on the basis of this categorization, now again that mechanical wave is categorized into two parts. One is longitudinal wave and the second one is the transverse wave, right? So we'll see that again. I am moving to the next. So like we are discussing about mechanical wave and the wave that requires the material medium. Okay. Again, this mechanical wave is further categorized into two. Okay. This is very simple. One is longitudinal wave, and second one is the transverse wave. Okay. Now, what are these things? We have to go through it very carefully. Okay. The first is longitudinal wave. What is longitudinal wave? Let me make you understand. Right? For this, you have to understand, because I have already told you about the disturbance. Because wave is something that is the disturbance that is happening in the medium, right? So this disturbance, on the basis of the disturbance, because disturbance means what? We are changing the position, initial position of the medium particles, right? So that changing that disturbance are happening different ways, right? So on the basis of that pattern, we have categorized the two types of again waves. One is the longitudinal and the second one is the transverse wave, right? So first we'll see about the longitudinal wave. So for that, I am making one very beautiful example. Suppose that this is the a medium, and there are three particles. I am writing A, this is the B, and this is the C. These are the air particles. I am writing, this is the air medium actually. Okay, and these are basically A, B, C are the medium particles. Now what happens when any wave enters? So we know that we have this simple condition of wave like that. We know that this is the simple formation of wave. We know that. So when any waves enter in the medium, this is the air medium. So what happens actually? The particle which are present in the medium, right? So here what would be that? That is air particle, right? So in case of longitudinal wave, what happens actually? The medium particle, the direction of wave is in this way, right? The direction of wave is along x-axis, but medium particle also start oscillating in their mean position, right? Suppose this is the mean position and it is along the direction of wave. This is very simple to understand, right? So as you can see that these are the mean position and particles start oscillating in its mean position. It means that if you see mindfully observe, you will see that the motion of the medium particle is along the direction of the wave. Very simple, right? Means suppose that this is the particle, right, and when any waves enter, right, so what will happen? That wave will create a disturbance in the medium, right, and due to that particle will start oscillating in its mid position. Suppose that this is the particle which is just at constant position. Now when any disturbance happening in the medium, so particle will start oscillating in its mean position. As you can see that particle is oscillating in its mean position and wave is moving in this particular direction. So direction of motion of the wave and the medium particle are along in same direction. We can say that parallel, right? Motion is along parallel, right? So we can on the basis of this motion we can simply write it down that in case of longitudinal wave, the direction of motion of medium particles is along the direction of wave motion. ओके, जो वेव का जो डायरेक्शन होगा, वेव की मोशन का जो डायरेक्शन होगा, उसी डायरेक्शन में पार्टिकल के भी मीडियम के जो पार्टिकल होंगे उनका भी डायरेक्शन उसी के अलॉन्ग होगा, राइट? सो दिस इज द सिंपल definition of longitudinal wave, right? And there are some example of that. What are the examples? So example is very simple. We can write down some examples. So this is a simple definition and we can write some example also. So example is very simple: sound wave. Okay, sound wave or ripples. Ripples on water. Okay, so these are some of the examples of longitudinal wave. Now we'll move and understand the concept of mechanical wave. Sorry, transverse wave, right? Because these two are the like we can say that mechanical wave का part ही है ये. So we'll see that कि what is transverse wave now, right? So transverse wave को हम बहुत simply define कर सकते हैं. Suppose that I will take the same example. Suppose that this is the air medium, right? Again I will take the same example. Air medium है, ठीक है? This is the air medium, and I have taken some particles like A, again B, and again C. These are the medium particles. Now any wave enters, any wave is entering, right, like that. Okay, now what will happen in this case? As you can see that the motion of the wave is along this direction, along x-axis you can say that. Suppose that I am like assuming that this is the x-axis, so the direction of the motion of the wave is along the x-axis. And in case of transverse wave, what happens? The direction of the medium particle is perpendicular like that. The medium particles start like oscillating in their mean position in the perpendicular direction to that of the wave. Understanding, right? As you can see that the direction of the wave is along x-axis and the direction of motion of the particles, medium particles, are just perpendicular to the wave, right? So suppose that this is the direction of the wave and this is the direction of the medium particle, so both are making an angle of 90 degrees. So we can say that the wave, so we can simply define that the direction of the medium particle is perpendicular to the direction of the motion of the wave. Very simple, right? So this is the example of transverse, right? So we can very simply define that in case of transverse wave, we can simply define that in transverse wave, the direction of motion of medium particle is perpendicular, direction of propagation of medium particle is perpendicular to the motion of perpendicular to the motion of wave. Very simple definition. Okay, very simple. The direction in case of transverse wave, the direction of motion of the medium particle is perpendicular to the direction of motion of the wave, right? So what would be the example? Example is very simple. We can write it down the example. Examples are very simple. Example is all type of radiation. So in that particular radiation we have electromagnetic wave. So I am just writing the example here with different color. Example would be an EM wave, that is electromagnetic wave. Okay, so now we have very good idea about the different types of wave. What is actually wave, right? We have very much fundamental idea. Now the idea of a wave we have cleared. Now we'll see some like other generic terms which are there in this sound, right? So first we'll see that how sounds produce, because this was the very different, because this is the different aspect of the sound chapter, right? Because we have to, before understanding the concept of all the topics or all the subtopics which are there in this sound chapter, this wave, the understanding of wave is not given in much detail, right? So that's why this was a separate discussion on the wave, right? Now we'll see that production of sound. The topic that we should start is the production of sound, right? So I'm just moving to the next slide. So the next topic is our production of sound. Production of sound. How sound produce. This is the first topic that we should understand, right? So you guys are very much aware that for the production of sound we need any kind of disturbance, and for that disturbance we need some external pressure. Suppose that right now I am having something like this is the screen, right? So now I just want to create some sound. So what I will do, I will apply some pressure. I am just applying some force to external force to this board, and there is a sound which is coming out. It means that for the production of sound we have to understand that there is something that is called vibration associated with this, right? It means that if we are applying some force to any kind of object, right? So there is a vibration which is being produced at that atomic level, right? So we can say that for the production of sound, the very simple term, it is the vibration of medium particle. Okay, so when we apply some force, some pressure to any kind of medium, so the particle of that medium start vibrating, and due to that vibration there is energy, and that energy is actually transferred to us in the form of wave that we have already discussed, the different types of wave, right? So for the production of sound we need some kind of vibration. Understood? Now this is a very simple. now you tell me, the second topic would be very simple, that is the propagation of sound, right? Propagation of sound, right? So propagation of sound. Propagation of sound. Okay, now we'll see that how sound propagate, how sound actually travels in the medium. This is very important to understand, right? So do you think that sound really requires the medium for its propagation? As we have seen that there are two types of wave, because sound is basically a form of wave now. So we have seen that some sounds really require the material medium for its propagation, and we have seen that some sounds doesn't require any material medium, and the example was electromagnetic wave, right? So we can that how actually sound propagate, right? So we have seen that sound actually propagate in the medium in the form of energy, right? How that is possible? That is possible with the motion of the medium particle. Actually medium particles are oscillating in their main position, right? But there is no actual movement of the medium particle, right? So we can say that the minute observation, we can say that the net displacement of the medium particle will be zero. Understood? In case of any kind of sound wave, we can say that. So what is happening? Medium particle is oscillating in its main position, right? And that oscillation is being transferred to the neighboring particle, and that neighboring particle is transferring its energy to the next neighboring particles. In this way there is a transfer of energy from point A to point B. Understanding? Suppose that if I want to make you all understand and feel this concept, suppose that I am having any medium, right, and there are different particles here. Okay, so this is one medium and there are different particles here which are aligned like that, right? This is a simple air medium particles. I am just making you feel this concept, right? Because this is very imagination chapter, imagination topic. You have to imagine the concept, right? Now what happens actually? Suppose that I am bringing here any kind of source of wave, right? Source of sound. Suppose that this is the you can say that this is something speaker kind of something, right? So what happens when we play some sound here? So what is happening? There is a vibration, right? Here it is a vibration which is, sorry, okay, so I have written wrong. Okay, so there is something which is vibrating. Okay, and due to this vibration, what is happening? What is actually happening? The membrane of this tabla, or you can say dholak, what is happening? That is vibrating in its main position, and due to that vibration, it is like applying some energy. It is just giving some energy to these medium particles, right? And when these medium particles feel this vibration, they start moving from its main position. So what will happen? They will just move in this forward direction, and this again neighboring particle will just allow some energy to the next neighboring particle, and in this way actually and medium particle is not moving. So net displacement, we can say that net displacement, right? Net displacement of medium particle is zero. Okay, so there is a to and fro motion, right? To and fro motion, to and fro motion of the medium particle. Okay, to and fro motion of the medium particle, and due to this to and fro motion, there is a transfer of energy from point A to point B. Suppose that there are 2 points. There is one point A and there is a point B, right? And some information has to be sent from point A to point B. So what will happen? Does the medium particle will travel from A to B to transfer the energy or to transfer that form of information? No. Actually, medium particle, what will do? It will just give information to its neighboring particle, and again this neighboring particle will give the information to the next neighboring particle, and finally that information which has already been sent will be transferred to you just by the neighboring particles. Means the particles which has actually received the information is not coming to you and just sharing you the information, right? Actually they are transferring in the form of, like, you can say that, chain, right? So actually medium particle is oscillating in its mean position in the to and fro motion, right? To and fro motion, back and forth motion, right? Up and down motion, oscillations, right? So we can say that there is a oscillatory motion, there is a to and fro motion of the medium particle, and due to this motion there is a transfer of energy from the from point A to point B, right? And that is why there is a requirement of medium. Okay, that is why there is a requirement of medium. If there would be no medium, means there would be no any medium particle, and if there would be no any medium particle, it means that particles are the carriers of the energy. So no any you can say that there will be the transfer of or the propagation of sound. But some sounds are there, some form of energy are there that are electromagnetic waves that doesn't require any kind of material. So that is a different case. We'll see in the coming session. So now we have understood the concept of propagation of sound and how sound propagate and production of sound, right? And we have also discussed the concept of different types of waves, and we have seen that there are different types of waves, right? Now there are some characteristics of the waves that you have to know, right? Like what is wavelength, what is amplitude, what is the frequency, and what is the time period, and what is the wave velocity. So these are the 5 terms that you have to know in this chapter for solving the numericals and have the basic understanding of this chapter, right? So the next topic is characteristics of wave. The next topic we can write it down. Characteristics of wave. Okay, so now what are the characteristics? Let me make you all understand, right? So I have written characteristics. So first characteristics we have to understand is wavelength. Okay, the second characteristics is amplitude. Okay, the third characteristics is frequency. Okay, the fourth characteristics is time period. And the fifth characteristics is wave velocity. Okay, so we have to understand this very fundamental concept, that is wavelength, what is amplitude, what is frequency, what is time period, what is wave velocity, right? So all these terms have different symbols. So first we will understand about the concept of wavelength, right? So I am moving to the next slide. So first we are going to understand the concept of wavelength, right? So wavelength is represented with a word that is the lambda, right? This is the lambda word. So we have this term lambda, right? This is the Greek word that we are representing. Now what is actually wavelength? Let me make you all understand, right? So as we have seen that when we have the discussion of wave, right? We have seen that any kind of disturbance, right? So that basically the sound is a form of energy, right? So that form of energy to represent correctly, we have just given the pictorial representation of that sound wave or that wave in the form of wave, right? So what is that pictorial representation? So that pictorial representation is very simple. Okay, so I am drawing here that pictorial representation here. Okay, so now as you can see that this is the simple wave, and in this way we are representing the wave. Understood? So this is the pictorial representation of energy. Pictorial representation of sound energy. Okay, the pictorial representation of sound energy, right? So now what are the things that are associated with this? We have to understand. Okay, so this, the y-axis, we are representing the displacement, right? The y-axis is displacement, and this x-axis I am representing the time. Understood? Now what is basically this? So as you can see that this elevation, this particular elevation, right? I am talking about this particular elevation, right? So this particular elevation we call crest. This 2-point elevation we call crest, and the down one we call trough. Right? So down like that will be the continuous pattern, and this is called sinusoidal pattern, right? This is the sine graph. Okay. Now, what is actually the concept of wavelength? So the concept of wavelength is very simple. The distance between two crust and two trough. Suppose that if I want to extend this line, right, and then I am just making one more pattern line. Okay. So as you can see that this is also trough, right? So the distance between two crest or two trough. Okay, the distance between two crest, successive crest and successive trough को हम बोलते हैं wavelength. Okay, so this distance we call it as a wavelength. The distance between two successive crest or two successive trough we call wavelength, right? So what will be the unit? Unit is very simple. What will be the SI unit? SI unit, since it is a measure of length, so definitely it is meter or m. Understood? So this is the very simple definition of wavelength. It means that the distance between two crest, successive crest or two successive trough. Okay, so this is the simple definition of wavelength. Now we will see that what is the definition of the second topic that we have to understand. The second topic we are going to understand is the frequency. Sorry, that amplitude. Okay, the second is amplitude. Amplitude we represent with capital A, and simply SI unit is very simple. It's meter. Okay, SI unit of amplitude is also meter, and I am representing with small a. Okay, now what actually is amplitude, right? So amplitude is the maximum displacement of the medium particle from its mean position. It means that suppose that this is the medium particle, and this particle has traveled a distance of this much, and again this particle has came, and again this has moved in this. So this is the mean position, right? So displacement of the particle from its mean position. So this displacement, this is only called amplitude. Okay, but in the form of wave, if I want to draw in the form of wave, so we can say that it would be very simple. It would be like that, right? Suppose that this is the two axis which I have drawn, and this is the wave, right? So this maximum displacement of the medium particle, right, from mean position to this is only called amplitude, right? So this is called the amplitude. Okay, and I am representing with A. It means that the maximum displacement of the medium particle from its mean position. So this is the basically the simple displacement and time graph, right? So maximum displacement of the medium particle from its mean position is called, okay, so this is the graph. So the maximum displacement of the medium particle of this elevation we call the amplitude, right? This elevation we call the amplitude, right? So now we have we have understood the concept of wavelength and the amplitude. Now we'll see some more topic in the next class. Okay, so thank you, bye bye.